Alkenes will react with cold concentrated sulfuric acid to form alkyl uh, hydrogen sulfates. Two conditions to convert alkyl hydrogen sulfates into alcohols. We want to add water, adding water, and then warming the reaction mixture. So we got ethene plus H2SO4 to form ethyl hydrogen sulfate and alkyl hydrogen sulfate. Cold concentrated sulfuric acid reacts with alkene, forming ethyl hydrogen sulfate in electrophilic addition. Yep. And then you've got your ethyl hydrogen sulfate plus water, and then we obviously warm the reaction mixture and we form ethanol and alcohol plus H2SO4 sulfuric acid. So we add cold water and we warm the product. And these two conditions, adding cold water and warming product, it hydrolyzes to form an alcohol. So that's a fancy word you can say instead of adding cold water, warming the product, or warming the reaction mixture. Why is sulfuric acid considered a catalyst? Because the sulfuric acid isn't used up. If you look in the first reaction, plus H2SO4 with ethene, then you can see at the end of the second reaction, we still have this H2SO4 sulfuric acid. It's not being used up, therefore it is considered a catalyst. So the actual mechanism of itself with alkenes reacting with, in this case, ethene reacting with cold concentrated sulfuric acid to form ethyl hydrogen sulfate and then to form ethanol. So from the middle of the ethene bond to the hydrogen positive, oxygen positive negative, middle of HO bond to the oxygen, and obviously your H2SO4, original structure of that. Now the carbon's positive, oxygen is a negative charge with a lone pair of electrons. It bonds to the carbon, and now you form this. What's this? Ethyl hydrogen sulfate, an alkyl hydrogen sulfate. Then we add cold water and then we warm the product. Then what happens is we form an alcohol. Now what is very hard to notice is like, how do you form the alcohol and how do you know which alcohol it is? Because for this part, you've got your alkene, this mechanism, you have to obviously memorize it. Arrow go here, curly arrow here, minus charge, a lone pair of electrons, bonds to carbon, which is positive. Then you form this. Pretty simple, right? Now to name it, ethyl hydrogen sulfate, alkyl hydrogen sulfate, ethyl hydrogen sulfate. Now once you add cold water to warm the product, what you can see is that everything else is the same. The CH3 here, this CH2 here, here is the same as previous, but all that's happened is we've added a H to here. So one of the hydrogens goes here, an OH, and then you're left with your original H2SO4, because remember the H2SO4 is not used up. That's why it's considered a catalyst. Sulfuric acid is considered a catalyst as it's not used up. So we're still going to have the H2SO4. So you can draw out the H2SO4 and then be like, okay, so we've added water, and what we got? OS double bond O double bond O OH. And then we've got two hydrogens. And obviously one hydrogen is going to bond here. So where's the other hydrogen going to go? It's going to bond here. From ethanol plus your H2SO4. And the overall reaction, ethene, H2C double one CH2 plus H2O, arrow H2SO4 to form ethanol. But obviously you form your ethyl hydrogen sulfate and then you convert into your alcohol by adding water and warm reaction mixture. But in this case, we just simplified it to the alcohol ethanol.